All right, 723, how fast am I going? In a previous lesson, we calculated the average rate of change between 2 points. Today, we're going to investigate what happens when those 2 points get closer together. So let's start here. D of t, let's zoom in, sorry. D of t equals 10t squared. Okay, so calculate the average velocity of the car from t equals 5 to 5 plus h, where h is 0.5, 0.1, and 0.01. Okay, so at 5, we got 25 times 10 is 250. So there's a point. Then we'll do 5.5. So that's 5.5 squared times 10 is 302.5. So then we'll calculate slope. 302.5 minus 250 over 5.5 minus 5. And we get 105. Okay, we'll do this again. 5 and 250. And then 5.1. And you get 260.1. So then slope, 260.1 minus 250 over 5.1 minus 5. And you get 101. And then the last time we'll do it again, 5 and 250. And now we'll do 5.01. So this is 251.001. So 251.001 minus 250 over 5.01 minus 5. And you get 100.1. Okay, so what's happening to the value of h, right? It's approaching 0. What is happening to the velocity? It's approaching 100. Okay, so understanding that idea of as h approaches 0 is where we're going. So as these 2 points get closer and closer together, we're approaching something, right? So in the previous problem, h was changed while t equals 5 did not change. This causes repetition in your average velocity, right? To simplify this process, complete the bar below to calculate the average velocity of the car from 5 to 5 plus h. Okay, so they've done this for us, right? So they've said 5 is 250. And then 5 plus h, they plugged into the function. So right here, right, you can see that they plug in 5 plus h into the function. So it's like 10 times 5 plus h, probably need some more room here, 5 plus h squared. Okay, and then what happens, right? So, so let's do that, right? So this is 25 plus 10h plus h squared times 10. So that's 250 plus 100h plus 10h squared. Then we're going to go minus y1. So minus 250 over x2, 5 plus h minus x, which is 5. So 250 should go away, 5 should go away, right? And I'm left with 100h plus 10h squared over h. Now it allows me to plug in whatever that h value is, so I can actually simplify this. I can take out an h. And now it allows me to put in that h value and get the the velocity, get the velocity at whatever that h value is close to 5. So like 0.5, 0.1, and 0.01, right? And so you can see there where we would get these same answers that we were getting. Okay, what about 4 and 4 plus h? So this is just going to change, this part. And then we would do the same thing. So we're going to do 4. 4 squared is 16 times 10 is 160. And then we'll do 4 plus h. So again, this is going to be 10 times, let's do this, 4 plus 4 is 16, plus 8h plus plus h squared times 10. Right, so then what's our expression going to be here? 160 plus 80h plus 10h squared minus 160 over 4 plus h minus 4. 4's cancel. 160's cancel. Right, now we have 80 plus h squared plus 10h squared over h. Factor out an h. We'll have 80 plus 10h over h, and the h is canceled. So our expression is 80 plus 10h. Okay, then we could calculate the h values, like 0.1, right? We should get like 81. 0.01, 80.01, right? 3.99, right? So you're just plugging in those h values, how much difference there is from that number to 4, and you're plugging it into this expression. Okay. All right. And then 97 is kind of like last. We're just calculating slope over those smaller intervals, right? Okay, over and over and over again, you're calculating smaller intervals, smaller intervals, smaller intervals. We're approaching this idea of instantaneous rate of change at an instant.